Similarly, if I want to represent any other data set for the regression task here, so in order to do it, let me import the another very important data set here, and that is the Boston house price data set. So from sklearn dot datasets import load underscore Boston. Okay, so that is another data set here. So let me call it data underscore Boston, and it is basically the Boston data set, and load underscore Boston. After it, let me call it x2. x2 is the data underscore Boston dot data, and similarly the y2 are the data underscore Boston dot target. Okay, so y2 equal to, okay, so now these are the two elements here. So what is basically the data Boston composed of? So data underscore Boston dot feature names. What are the features? So there are different features here like crime rate and similarly others here, and these are related to the price of our data set. So let me plot the crime rate and with respect to the rate of a house. So here again now plt dot scatter. Okay, so what will be the data here? So x2, and that is the 0th element here. Similarly y2 is the feature here, and similarly line width again is equal to 5. So let me plot it. So that is the plot which shows the inverse relationship between the crime rate and rate of the houses in Boston. Okay, so let me increase the size of my plot here. plt dot figure. Okay, so fig size equal to, that is 12,8. in order to enhance the visibility. So plt dot grid. Now you can very clearly see here that the relation is inverse. Similarly, now let me increase it some more. It is now clearly shows the location of different data points. Okay. Similarly, now in order to show different other parameters here, so now representing the size of these points with the age of a house. So what is the here? So that is basically 0, 1, 2, 3, 4, 5, 6. So that is x, and that is 6. Okay, so now what is the issue here? Index x is out. Okay, that is x2 here. Sorry, so that is x2 here. What is the issue here again? Oh, sorry, that is the size. Okay, so now we can see that the size is almost constant because the age is almost same. Let me choose another parameter here. So let me choose the text or the radius here. So dis is another parameter, so let me choose it. Okay, so now you can also see that it is again almost similar. The 8th one is the radius, or text is 9th one. Okay, So now you can see that these are basically changing here. So these basically are different parameters, and we can use them here as well. Similarly, another data set which is also of use, and that is the Linnerrud data set. So let me import it. So from sklearn.datasets import load underscore Linnerrud. Okay, so that is another data set which basically shows the relationship between the physiological and different health related or parameters here. So let me import it here. So data underscore Linnerrud. So let me LIRD, that is the load for Linnerrud, and it will be here, and let me represent it. x3 is equal to data Linnerrud dot data, and the targets will be here. Okay, so these are the parameters here, and let me see that what are the parameters here. So dot feature names. So what are the features? Features basically different exercises like chin-ups, sit-ups and jumps, and what are their effect upon the targets, and what are the targets upon the weight, waist and pulse rate of a person or of an athlete. Okay, so now let me plot them here. So plt dot figure again, so fix size equal to again 8. Okay, so plt dot scatter. So here let me write the x3, and x3 is basically, let me write it as a weight and weight with this. Okay, sorry, that is basically the exercise, and exercise, let me write the jumps here. So jumps with respect to the weight of an athlete. So this is y3, so y3, and this is the first row here, and here it will be line weights again 5, and plt dot grid here. Okay, so that is the relationship of the jumps and the weight of a user. So if more jumps, then weight loss will be higher, and vice versa. Okay, so less number of jumps will be having the higher number of weight. A person who is jumping with the higher number of iterations will lose higher amount of weight here. Okay, similarly, in order to show the pulse rate here as well, let me write s or size with respect to the waist here. So let me change it to x3, and that is the, or sorry, let me change it to y3, and y3 is the let me call it the waist size. Okay, so waist size is this one. So here the size is here. Similarly, color, what will be the color here? C will be the, let me choose the color with respect to the y3, and let me choose it the 2, which is the pulse rate. Okay, so now here we can see that the pulse rates are here, but what are these pulse rate? Let me again plt dot color bar. Okay, so these are different pulse rates which are represented by these this color bar. So lower now higher the pulse rate, the higher the color here, and that are represented here. So now similarly, in order to predict different weights here, we can use the regression line here, and in order to plot the regression line here, let me have a line plot. So plot, and that plot will be here it will be like the same value here at the x-axis, this x-axis, and similarly let me start it from 150. So 150 multiplied by the value here, and so writing the values here, let me run it, and I can already see here that a regression line has been appeared here. So that is the regression line, and I can increase or decrease the slope of this regression line by this parameter. Okay, so we can see that the slope has been increased, similarly decreasing the slope from here. Okay, so that is the slope here, and similarly the y-intercept can be increased or decreased from here. So that's it. As this regression line is not the optimal one, because I am manually changing the values of the slope and the y-intercept by myself, but the efficient way is to increase or decrease their values by using the optimization method. Okay, so that's it for today, and I will see you with some more examples with more data sets very soon. Okay, till then, take care of yourself, and I will see you soon.